Great. Okay. So we have this graph here. This is part of the Parabola lab. And it's saying to find the vertex, write the equation line symmetry, graph on graph here. We're just going to just talk about it, really. That's what we're going to do. So what's your vertex here? 2, 0. An axis of symmetry is a line that goes right through the middle. It's not an asymptote, by the way. Just, it's not an asymptote, just the axis of symmetry. What equation would that be? It's a vertical line. How would I write the equation of that dashed red line? Perfect. Thank you some more. X equals 2. And it cuts in half, as it should. Okay. So now we're going to do some movements, right? This is the big part of this unit, is we're moving graphs around. Okay. So it says sketch 2 more graphs. You want the same vertex. And you want to open up. So that's what part D is saying. I'm sorry, part B is saying, my bad. Part B is saying keep the same vertex and have it open up. So we talked about this. We could put a 2 in front. Hold on. And put a 4 in front. So notice what just happened. By simply introducing a number to the left, you're multiplying the function by 2 or 4. What does it do to the graph? It stretches the graph vertically. So this is what we want to have this discussion, that when there's a number here, this causes a vertical stretch. And we're going to see this again in page 2 of these notes. For example, if I plug 1 in for x, see it's here, and it's here. If I actually see like 1, 1 roughly, 1, 2 roughly, 1, 4 roughly, as it should, because you're multiplying the y values by 2 or 4. Let's now move on to part D. So again, we want to keep the same vertex, but instead of opening up, we want to have it open down. What do I change in the equation to make it open down? What do I do? Well, instead of let me close these. Let me close that one. Instead of a positive number in front, there should be a negative. Because what's happening now? If I plug in values for x, sure, but then like 3, I have 2 positive numbers, but then I have a negative afterwards. Makes it negative, right? That's -1 times all that time. So if you multiply all of it out, you'll get a bunch of negative numbers. If you plug in a bunch of values for x, you get a bunch of negative y values. So that's what's happening. That's the negative causes it to flip. And this is all going to come together on the second page. Lastly, if you move the vertex to -4, 0, right now it's at 2, 0, right? So I want it to be over here. How far does this vertex have to jump? Or how far does this vertex have to move to the left to get to over here? 6. So I'm gonna it's weird. I know it's going to be very weird. You're actually going to add 6 to these numbers. I know it's very strange. You're going to add 6, which is, it seems counterintuitive. But if I add 6 to both those, it'll be +4, +4. +4, +4. If you think about it, if you plug in -4 for x, you do get 0. So I know it seems a bit counterintuitive, but essentially what I did was I added 6 to each of those, and that's called a transformation. That's where you're shifting horizontally 6 to the left. Okay, now this is the part I really care about. This is where it's all going to come together. I'm going to give you the general equation, and we're just going to make some generalizations about it. Okay, so I want everyone writing this on their page somewhere. This is the general equation for a problem. A x minus h squared plus k. Oh, you should have from yesterday, but or 2 days ago. But if you don't, I have extra ones. I'll put. If you can't find yours, I'll leave extra ones. All right. So let me explain what each of these things are. A is for the vertical stretch. So we definitely want to write this down. A is for the vertical stretch. slash reflection about x-axis. H gives me a horizontal shift. And K gives me a vertical shift. Okay, this is the beginning of everything. Um, Transformations are a big deal in pre-calculus and calculus. We're going to spend a lot of time transformations for the next 7 to 8 months. Right now it's October, like, we're going to be together for till May or June, right? So we're going to talk about H and K often. Now, just so you know, H is counterintuitive. That's weird. You have X minus H. So if you have X minus 1, H is 1. It needs to go 1 right. But K is intuitive. If you have +2 on the outside, you go 2 up. If you have -2, go 2 down. A makes the graph skinnier or fatter, or skinnier or wider, whatever adjectives you want to use. And if it's negative, it flips. When I say flips, flips about the x-axis. Reflection is a more proper way of saying it, but if you say flip, I know what you mean. So now, let's look at part A. Find a way to change the equation, make the parabola stretch vertically. Okay, so y equals x squared looks like this, roughly. What if I do y equals 2x squared? Where does that dot go now? The dot at 1, 1 now becomes what? 1, 2. Exactly. 1, 2. So it will look narrower as a result. It will look narrower. Okay. Let's do a compressed vertical. So it's going to be y equals 1/2 x squared. So what happens in this case, my graph will look like this. Where do I point out 1, what? 1, 1/2, right? So now it looks wider. Okay, so just think about it, right? It's not slope exactly because it's not linear, so don't say slope. But if you want to think like that, you can. The graph gets steeper when that gets larger. The graph gets not as steep when it gets smaller, as it should. It's not increasing as quickly if it's 1/2. Let's increase more quickly when it's 2 to 5. And the y values simply get multiplied by that number, by 2 or 1/2, depending on what number you got there. Okay, let's take a look at part C. We want to open down. So what should I say now? Y equals what? Good, y equals negative x squared. So if I graph that, it's going to look like this now. And that's a crappy looking parabola. My apologies. So you get 1, -1. So you can see what A is doing. A is either making the graph narrower, wider, or flipping it over. So those are 3 things that A will do, right? So that's the function of A in front of the parentheses, or in front of x squared. Okay, question on that one? All right. Now let's look at part D, E, F, and G. And then we should be able to finish these notes in about 5 minutes. Okay. 5 down. Okay. I'm going to say y equals x squared what? What am I going to put after the x squared if I'm going 5 down? That should be intuitive because you're dropping by 5. Exactly, 100%. That should totally be intuitive. So in this case, instead of 1, 1, it's going to be kind of weird. My vertex is going to be at -5, by the way. So 1, 2, 3, 4, 5. And here's 1. That's a 1 comma -4. Because previously it was up here. Everything went down 5 units. So if I made a table, for example, for y equals x squared, 0, 0, 1, 1, -1, 1, right? That makes sense for y equals x squared if I plug it in. What if I make a table for the green curve? Let's plug in the same x values. If you plug in 0, you get -5. Plug in 1 and -1, you get -4. See how the y values drop by 5? As they should. You did -5. So that's a very intuitive change. Not that hard. Okay. Makes sense? We good? Okay, the horizontal ones are a little strange. I rushed this in last class. So I want to just be a little more deliberate about this time. So if you want to go 3 units to the right, you're going to do this. It means you want your vertex at 3, 0. If you want your vertex at 3, geez, I cannot do 3s for life of me on Zoom. Here we go. Okay, 3, 0. What do you think I'm going to put inside this parentheses here? If I want my vertex to be here now, so 1, 2, 3, I want my graph to look like this, right? What do you think I'm putting inside that parentheses? X plus 3, x minus 3. Yeah, exactly. Because that makes sense. And also remember our general formula is this, right? H is 3. So here your H value is 3. Because we want to go 3 right. The minus is built into the equation. So yeah, that's how it looks. That's your new equation as well. So now if I want to go left, what I'm going to write if I want to go left? X plus 3 squared. Now it looks like this. And we're going to practice a lot next week. So your H here is -3. I don't know why it says stretch vertically. Let's not worry about that. I don't know why it says that. Okay, G does everything all at once. Okay, doing a whole bunch of things all at one time. Okay, so let's take a look at G. You want to compress. You want to open down. So A is negative. You want to move 6 units up. So K equals 6. You want to move 2 left. H is -2. If you want to compress by a factor of 2, it means you use 1/2 for A, but A is negative because of that. So you want to do 1/2 for A. So your A is going to be -1/2. So here's how you write it. Y equals -1/2. X plus 2 plus 6. You write it like that because the 2 left means you have to have vertex at -2, 6. 1, 2, 3, 4, 5, 6. And it's going down and it's wider. You probably should make a table, to be honest, but we can just stop there. I mean, if you plug in, like, say, -1 or -3, I think you get, and that's square. My apologies. That's a square. My apologies. Please fix that. I think it's 5.5 for each of those if you were to work that out. Kind of hard to show on this screen here, but it's there. So that's how that looks. So we'll spend more time with this next week. You have some homework on it. Let me go pick up the homeworks right now. You guys just chill for a little bit. All right, you guys are great today. You guys do that as well. As I said, like, so I want to meet you guys individually. I'm just behind stuff. We'll worry about that later for now. Okay. So we'll go get the homework. Okay, this is just the homework due for the weekend. I think school did well.
Oh. Where is that? Where is that meat?
It's awesome. I'm gonna grab some food. I'll be back if you guys want to stick around.
Have a good weekend.
Yeah.
Good morning. Hey, Beth.